Next topic, phasor diagrams of transform. It's a very important topic. So try to understand this topic clearly. This is a transformer on no load. What I said just now, I discussed about no load condition. What is no load? So these two secondary windings are open circuited. When secondary windings are open circuited, what happens? Current will not flow through the secondary winding. So I1 is a primary winding. I1 is a primary winding current. I2 is a secondary winding current. N1 primary turns, N2 secondary turns as well as, and V1 primary applied voltage, and E1 primary induced EMF. Here primary circuit is closed, but secondary circuit is not closed. So here V1, I1, E1, and E2, V2, I2. I2 is 0 because it is no load, means open circuited. When it is no load, I2 is 0, therefore E2 is equal to V2. So phasor diagram. What is a phasor? Phasor is a rotating vector in anti-clockwise direction. So these are the vectors rotating in anti-clockwise direction. If you will observe here phasor diagram. So phasor diagram is nothing but we should indicate the process what is happening in the transformer with the help of phasors. So what is the process here? First of all, so voltage applies primary voltage. Next primary current flows. Next, because of this current, flux induces. So because of this flux, EMF induced in the primary winding, and the same flux links with the secondary coil. Then EMF induced in the secondary winding, E2. Next E2, if circuit is closed, I2 flows. When I2 flows, V2 appears. Understood? This is a process. If in case of no load, I2 will not flow. So only till process stops at E2 only. Understood? And so we should indicate all these parameters on a phasor as a term of phasors. So observe here please. So first I'm taking phi as a reference. So you can take any one parameter as a reference, because we should, if in order to indicate the process, we can take any one parameter as a reference. So here phi is taken as a reference. Phi is taken as a reference vector. This axis is a phi axis. Phi, here we can see phi. Phi is a magnetic flux. Why we taken phi as a reference? Because phi is constant. Here observe here the circuit. So whatever the operations are going on in this circuit, this phi is constant, remember. So transformer operates at constant flux. Transformer operates on constant flux. Understood? So we will take a phi as a reference. We will take a phi as a reference. So before phi, what parameters will come? Before phi, voltage will come. This is V1. So suppose take this as a reference. Take this point, suppose this point as a reference. So this entire, all things are rotating, all the phasors are rotating. Which comes first? So first comes V1, understood? First V1 comes here, understood now? So later I0 comes here, I0 comes to this point, later phi comes to this point. That's what a process. First V1 in anti-clockwise, next I0, current flows through the primary winding, next phi appears. So I0 is mentioned here, try to understand. So I0, so primary current, as I said, primary current is I1 I said, but here it is mentioned as I0. Why? Because I0 is called no load current. If load connects, then I1 appears here. So I1 has 2 points. Try to understand. Suppose if you want to get a current here, you should get current from the primary only. Means if current flows to the secondary winding, so particular required flux should be taken from the primary supply only. Understood? Whatever the energy should get from the primary itself only. Understood? So in the same, so why? Suppose if load connects here, some current increases from the primary than a no load condition. The following. So than a no load condition, some current increases in the primary. That increased current from the primary when load connects here is called load component of primary current. So primary current has 2 components. One is load component, another one is no load component. So why this is mentioned as I0 only? Why? Because this primary is supplying only no load current. No load current means a current. This primary is not supplying any load component current, but primary is supplying only current, which is called no load current. That's what I0. So what this I0 does? I0 do with 2 jobs. One is suppose a current flowing here. So here current is flowing through the winding. So this current produces magnetic flux, number one, and this current heats up this coil. These are 2 jobs done by this current. So these are indicated by I0. I0 is having 2 parts. One is Im magnetizing component, another one is IW working component. Working component is equivalent to heat developed in a core, and Im is in component equivalent to produce a magnetic flux. So Im is in phase with the phi. Understood? So this is what Im, vector sum of Im and IW is I naught. So this is a Im vector, this is a IW vector. Resultant of two vectors is a I naught, no load current, right? V1 I naught, which is a combination of IW and Im, and phi. Next, what happens? EMF induces in secondary winding, E1 and primary windings, E1 and E2. If you'll observe here, so these two must be in opposite direction. Try to understand. E1, E2 must be in phase, but E1 and E2 must be opposite, exact phase opposition with the V1. Why? Because so what is E1? Primary induced EMF, E2 secondary induced EMF. Why they phase opposition with V1? Because in order to satisfy Lenz's law, simple Lenz's law. What is Lenz's law? Effect opposes cause. Effect opposes cause. So E1, E2 developed because of flux, and flux produced by the current, and current produced by the V1. So cause for E1 and E2 is a V1, so must be in a phase opposition. Understood? So this is what a phasor diagram for a no load of a transformer.